we have some absent people who need to see it later. So, single replacement reactions. We've seen the patterns. We talked about the types of reactions, or you guys did that card sort about the types of reactions last class. So, people were recognizing the general pattern. But an element is going to replace another element in a compound in a single replacement reaction. So metal elements will replace metals, and nonmetals will replace nonmetals, but it doesn't switch. So this is just a big picture overview, and we are going to drill down further and look at more details as they come up. But we are going to, as I said, kind of look at more details, and then we'll see some more and more specific examples as we go. Sorry, I'm just trying to let some people in. By the way, this whole slideshow is posted actually at several points, but it's posted on the thing today if you needed to go back and if you missed anything. So the activity series, let me just quickly go forward and show you what that looks like. So that's when you hear me talk about the activity series, I'm talking about this thing, which is a list. And there are, I'll go back one sec to that other slide. I see, Thomas, you have your hand up. There's a list here. These are metals on the left and nonmetals on the right. So when you talk to me, or when I mention the activity series, that's what I'm talking about, and it's in your reference section. So elements can only replace other elements that are lower on the activity series, otherwise no reaction will occur, and we'll look at some specific examples. But when you are doing these types of reactions, you need to decide whether you're dealing with a metal replacement or a non-metal replacement. If it's a metal replacement, you're going to use that metal activity series, the one that's on the left. If it's a non-metal, you're going to use the one on the right. If no reaction happens, which we'll see, then you'll write no reaction, or you could use the words no, like there's a weird abbreviation that chemists use, no RXN. Okay, I think Thomas got in. So RXN, it's a weird abbreviation for reaction. It kind of sounds like a reaction if you kind of like mumble the letters a little bit, or RXN. So a weird reaction, a weird abbreviation that chemists use. And again, we'll look at examples of all this. Give you another little bit here if you need to catch up. Go ahead and use the hand raising thing if you need a bit more time with this slide. Okay, seeing a couple hands, I'll wait a bit. And as I said, you can you can go back if you need to, and this slideshow is linked, so if there's anything you do miss. Okay, so again, drill down here and a little more specific on a metal replacement. So what I have is kind of a generic form, but I've color-coded it to help emphasize metals versus nonmetals. So a couple things to remember, like from first semester. Metals are on the left side of the periodic table, that little stair-steppy thing that we drew in there. The entire left side So, aluminum, zinc, copper, that whole middle section, but also the first two columns of the periodic table, things like sodium, magnesium, calcium, potassium, all metals. There is hydrogen over there, which is a nonmetal, but that's the only exception. So this would be a metal replacement because the way you tell is the element that's by itself. So notice we have an element by itself, we have a compound. The element that's by itself is a metal. That's how you can tell it's a metal replacement. Metals can potentially replace other metals. So in this case, M replaces X, meaning M is going to boot X out of that compound and just shove X off to the side as an element and replace it in the compound. That's why it's called single replacement. If that is to happen, though, M must be above X on the activity series, on the metal series. Now, you need to follow everything we've been doing so far. Remember, my big emphasis in this reactions unit is the first step is always to write every compound or substance correctly first. So when we're writing this My, for example, we have to consider charge and how the charges would come together and balance and write it correctly. When you write formulas, you must write the metal first and then the nonmetal. That is simply the way that ionic compounds must be written. So Ym, for example, would be incorrect. And again, we're going to see specific examples of all this stuff. One kind of exception to this, or something that's a little bit different, is that if you look at that activity series, you'll find a hydrogen on it, even though hydrogen is a nonmetal. And this is because it has to do with acids, and hydrogen is always found in acids, and often we're curious how metals will react with acids. So hydrogen is going to be the same basic format as followed, but it's just a little bit of an exception in that in the case of hydrogen, you have a metal replacing a nonmetal, and that kind of thing. These state symbols are just a pattern. Metals except mercury, which mercury is never going to come up on this. All metals are solids at room temperature, so our two metals involved are solids. But then the other things are going to be aqueous. Let me know, you can use the hand raise if you need a little more time on this slide. Okay, I see a bunch of hands, so I'll wait. So I'm gonna move this on, and as I said, I just want to make sure we get some practice in. You can go back and consult these notes, which are linked. Okay, so in a non-metal replacement, so again, the pattern is the same, and the kind of overall idea is the same, except for the fact that when it comes to nonmetals, which are represented as blue here, nonmetals can only replace nonmetals. So the pattern is that N is going to form a compound with X. In other words, we're not going to form like NP. We're not going to have the N and the P match up. We're going to potentially, N is going to potentially replace P. Now, when we say nonmetals, really for the ones that we're going to look at, it's actually halogens, which I'll remind you are the group 17, the second to last column, fluorine, chlorine, bromine, iodine, those, which are all diatomic, which is why I have the subscript 2 here. Their state varies. If you're sitting in the classroom, you can tell their state by their color on the classroom periodic table. Fluorine and chlorine are gases, bromine's a liquid, iodine's a solid. We saw iodine, remember, in class when I did the purple haze thing. You saw that was a solid yourself with your own eyes. So that's why I didn't put a state this time, because that could be different. But same idea, the things that we're reacting it with must be aqueous, and also the other product is going to be aqueous. And then for a nonmetal, we're consulting the nonmetal series, and again, it is the position of N relative to P. So after all this, we shall be just about ready to look at some specific examples. Go ahead and use the hand raise if you need a bit more time on this one. Okay, I'll wait a bit. So, I think, okay. So we're going to go through some examples. I'm going to switch actually to my notepad thing. But I would suggest you write down these examples in your notes. So here we have, so I've got a couple examples, and we're going to do about as many of these as we can. I've got the first couple actually color-coded to really help you see what's going on. So when you're looking at a single replacement reaction, the first thing you want to decide is this a metal replacement or is it a non-metal? And the top one's a metal replacement. And I can tell that because aluminum's a metal. I mean, I know aluminum's a metal because of my real-life experience, as you do too, if you stop to think about it for 2 seconds. But also because it is on the left side of the periodic table, the left side of that stair step. So this is a metal replacement. And so the question is, where is this aluminum compared to copper? Okay? Is it above it on this list over here, this activity series? If so, there will be a reaction. If it is not above it, there will not. And here, yes, indeed, there will be a reaction because aluminum is right there. It's between magnesium and manganese, and copper is quite a ways down towards the bottom. So it's kind of like the toughest, the strongest, the beefiest ones are all up at the top. And then as you go down, they're kind of wimpier and wimpier and wimpier and more easily replaced. So another thing that's very critical to point out right now is in any chemical equation, it makes absolutely no difference. Like, for example, this could be written like this, CuCl2 plus Al. That makes no difference at all. I would still be comparing the element by itself to this. And it also doesn't matter the order that I write the compounds in as the products, as long as I write each formula correctly. So, for example, here's the pattern. This reaction will happen. So what will happen is the element copper gets booted off and is just in copper's normal form. Copper's not diatomic or anything. And it's a solid. So we're going to form the element copper. And then the other thing that we're going to form is, so I need to think about charge here. I need to think about aluminum. Aluminum forms +3 ions. chlorine forms -1 ion. So as always, as we've been doing so far, always in this unit, I need to think about what would be the formula of that compound between aluminum and chlorine with a balanced charge. It would be like so, AlCl3. 1 aluminum, which is +3, matches up with 3 chlorines that are -1. And then just by patterns, that is always aqueous. And again, I could have written this as like that. Totally. Now, we're not quite done with this one yet, but switching the order to those makes no difference. What I can't do is write one of these things incorrectly. Like, for example, AlCl2, that's not right. Or Cl3Al, that's not right because that doesn't follow the rule of we always write the metal first. So as the order that I can swap those things places and it doesn't matter. Any questions before we balance this? Any questions about all that so far? Okay, so as we've been doing all along, the second step is always balancing this thing. So now we need to balance it. I'm just going to clean this up a little bit. Okay, so let's balance the chlorines. Let's get 6 chlorines on each side. If I put a 2 there, that makes 6 chlorines. I put a 3 there, that makes 6 chlorines. Now there's 3 coppers. Now there's 2 aluminums. So that one's done. Questions about that? Okay, looking at the second one here, we have, it's the opposite of the first one, if you notice. The first one is aluminum with copper chloride. This is copper with aluminum chloride. So if you've eaten your Wheaties today, you might realize that this is not going to happen. But the question is, where is copper compared to aluminum? The element by itself compared to the element in the compound. Regardless of the order they're written in, that doesn't matter. And the fact is that copper is below aluminum, so this is going to be no reaction. So if you saw this on a test, quiz, wherever, you would either write the words no reaction or feel free to use RXN as an abbreviation. That's it. That's all we can do with that. If you put a piece of copper into aluminum chloride, nothing's going to happen. So that was no reaction. Okay. Let's look at another example. So again, the first thing we ask ourselves is this a metal replacement or is it a non-metal? The way you can tell is the actual element by itself, is that a metal or non-metal? Magnesium is a metal. It's on the left side of the periodic table. Now, the question, again, it doesn't matter whether it's the thing on the left or the thing on the right. The question is, where is this metal compared to this one that's in the compound? That's what matters. And so the question is magnesium above silver? And it is. Magnesium's, I don't know, 5th or 6th one down. Silver's pretty far down towards the bottom. So yes, this is going to react. And the products of the reaction are going to be the metal silver, for one thing, which is a solid. And then we ask ourselves, okay, magnesium is +2. This is a polyatomic ion nitrate. Nitrate, I know because I have it memorized, but you might have to look on a list of polyatomic ions to remind yourselves that nitrate has a -1 charge. So therefore, magnesium is going to be +2. It's going to react with 2 nitrates. Remember, I'm not allowed to change the subscript 3 on the nitrate. I enclose it in parentheses and I put a 2. Notice we don't put a parentheses when there's only one of the polyatomic ion like there is. And then this would be aqueous. Once we've done that, then we balance it. So let's balance the polyatomic ion first and as a whole. You got nitrate, put a 2 there. Now that one's done. Questions about that? Okay, so let's look at another one. Okay, so this one is a metal replacement, because calcium is a metal. And what I'm saying to myself is, where is calcium compared to hydrogen? Now, as I was saying earlier, hydrogen's a little bit of an exception because it's a non-metal, but we do kind of almost think of it as a metal in these types of reactions. Calcium is above hydrogen. Hydrogen's 70 or 80% of the way down. It's pretty far down. Calcium's pretty far up. It's above that. So the pattern is going to be the same. The element hydrogen is going to get booted off into its elemental form. It's just that in the case of hydrogen, a couple things to remember. One is that it's a gas, and also that it's diatomic. So in its elemental form, it's going to be produced in the form of H2. And then the second product is going to be calcium, which we need to think about the fact that it's in the +2 column, chlorine, which is in the -1 column. So the formula for calcium chloride, which is what we're forming here, is going to be CaCl2. So I'm always taking the time to think that through, think about charge balancing, and get that formula written properly. Oh, notice a big mistake, especially in like this situation, is students do sometimes like want to write that. That is not correct. And the reason that's not correct is because it's kind of like spelling a word wrong or doing the incorrect grammar. It is just not the way that formulas are written. The metal must be written first. So we cannot do this. That would be counted wrong. So you always write the metal first in any formula. And then, the second step is always to balance. If I put a 2 here, that's going to balance it because there's going to be 2 hydrogens, 2 chlorines. Questions about that? All right. Let's keep it going here. Let's look at a couple more. So here we have the first example we've seen so far of a non-metal replacement. And the reason it's a non-metal replacement is because this time the element that's not part of a compound is fluorine. And so remember, metals replace metals, non-metals replace non-metals. So the question is, first of all, where is fluorine in comparison to chlorine? Same idea though. If fluorine is above chlorine, this reaction will happen, which it is. One thing that's handy about the non-metal replacement list, activity series is that it's in the same order as the periodic table. So you can actually just look at the periodic table for the non-metals. It's in the same order. So remember, the overall pattern again is still the same. The chlorine is getting replaced. So the chlorine is the thing that goes off in its elemental form, which chlorine is a gas, and it is also diatomic. So as always, we need to write the formula for each substance involved correctly. And then it is Na and F that are going to join up. Sometimes people want to put Cl and F together. No, it's always going to be the Na and the F in this case that's going to join up. Na is +1, fluorine is -1, so their formula would be NaF. I'm always thinking about the formula based on charge when I'm writing these ionic compounds, which would be aqueous. And then lastly, we balance it, 2 fluorines on the left, so we do 2 on the right. Put a 2 there, now that one's done. Questions about that? This one here is the exact opposite of the one we just did. So, if you're really on the ball, you may realize already there's going to be no reaction, but it is a nonmetal replacement because this is a nonmetal. And the question I ask myself is, where is the chlorine compared to fluorine? And as we just saw, fluorine is above chlorine, so therefore this is going to be a no reaction. All right. So there is a few more examples in your workbook, and there's also a check-in that we're going to do today, but I just want to touch base on these ones. Like, for example, this top one is no reaction because it's a metal replacement, and the question is, where is zinc compared to magnesium? Zinc has to be above magnesium on the activity series. It's not. The one I want to really kind of touch base on right now is this one. So first of all, it's a nonmetal replacement. And then we say to ourselves, where is fluorine compared to chlorine? It is above it, as we saw in the other problem. So this reaction will happen. The thing that makes this one a little bit different is this Fe. And the reason I say that is because Fe is one of those, it's a transition element. It's in the middle of the periodic table. It's one of those that has an unpredictable charge. So we can still do this, though. So, well, first of all, the chlorine is going to get booted off in chlorine's elemental form. And we always write formulas for substances correctly, which in the case of the element chlorine is Cl2, because it's diatomic. Now I got to write this compound of Fe and F. But the problem is I need to know the charge of Fe, which we can't tell by looking at the periodic table. However, I do see on the left side FeCl3. Here's what I do know, that chlorine is -1. And I know there's 3 of them. So therefore, I got -3 worth of charge. I know the charge sums to 0. Therefore, this iron, in this case, is +3. So I have to do a little bit of extra work there to realize what the charge of the Fe is. But once I do, since fluorine is -1, it would be matched up with 3 of those there. And again, notice in the nonmetal replacement, I'm always ending up with metal and nonmetal as one of my other compounds. You're never going to put like 2 different nonmetals together or anything like that. Balance the fluorines. If I put a 2 here and a 3 there, that would get 6 fluorines on each side. And then if I put a 2 there, that's going to get 6 chlorines, and I put a 3 there, and then there's 2 Fe's. So now that one is balanced. Questions about that? Okay, I think what we'll do, I wanted to go through some examples, but also leave some time because we have, I've made a check-in today. We haven't done one of these in a while, but in Schoology, there's a check-in for today. So you do have about 8 minutes, which is probably enough time for most people. And especially if you go into the passing period a little bit, you should be able to get that finished. So if you would for me, please, go to Schoology, do the check-in for 217. You don't need, well, I guess you should probably stay on the call until at least 12:55. But let's go ahead and let's do that now. But I'm just going to kind of hang